Hi, welcome to the channel. I hope you are doing well. So in this session we are going to discuss about bubble sort. So the bubble sort is one of the sorting technique. Using this technique we will sort the given data. So to make the operation on the bubble sort we need some input data. So I consider input data as 15, 16, 6, 8, 5. The total number of the elements are 5, hence the n equal to 5. And the possible passes are n minus 1, that is 4. So let's begin with the example. So we have a given data as 15, 16, 6, 8, 5. So we need to take it as 15, 16, 6, 8, 5. Okay. So in bubble sort, so we have to start comparing with first element to second element. Okay. Then second element to third element. Then third to fourth, like this. Okay. So if the first element is greater than second element, only if the first element is greater than the second element, then we have to swap the elements. Swap the element means we have to change their positions. Now we have to start comparing. 15 is greater than 16? No. Okay. So if the 15 is not greater than 16, then no need to swap. Okay. We have to keep all the elements as it is for the next iteration. Okay. So in previous iteration we have compared 15 and 16, I mean first and second. Okay, now in the next iteration we have to compare second and third element, that is 16 and 6. Okay, so 16 is greater than 6, yes. Okay, 16 is greater than 6, then we have to swap means we have to change their positions, like 6 will come in 16 position and 16 will go to 6th position, and remaining things will keep as it is. Okay, now we have to compare 16 and 8. Okay, 16 is greater than 8, yes, so it's true means we have to swap. 16 will come into 8th place and 8 will go to 16th place, and for the remaining things we will keep as it is. Okay, now we have to compare 16 and 5. Okay, 16 is greater than 5, yes, so we have to swap. So we have to swap, and remaining things we will keep as it is. Okay, so now I will call this as pass 1. Okay, and at the end of the pass 1 I got the largest number of the given data. Okay, so now let's begin with the pass 2. Okay, for the pass 2 we have to take pass 1 result. Okay, see, again we have to start the same thing. 15 is greater than 6, yes, so we have to start swapping, and remaining things we have to keep as it is. Okay, then 15 is greater than 8, yes, then we have to start swapping. Okay, and remaining things we have to keep as it is. Okay, and 15 is greater than 5, yes, then we have to start swapping. Okay, now 15 is greater than 16, no, so we have to keep as it is, no need to pass. Okay, and now I will call this as pass 2. Okay, at the end of the pass 2 we got two largest element from the given data. Okay, now let's begin with pass 3. Okay, for pass 3 we will copy this data. Okay, so again we have to do the same thing. 6 is greater than 8, no, so no need to swap, we will keep all the data as it is. Okay, and 8 is greater than 5, yes, so what we have to do, we have to swap here in this case. And we have to keep remaining things as same. Okay, now we have to start comparing 8 and 15. 8 is greater than 15, no, so we will keep as it is. and 15 is greater than 16? No. So we'll keep the same thing. I will call this as pass 3. Okay, at the end of the pass 3 we got 3 largest numbers from the input data. Okay, now let's begin with pass 4. Okay, so again we have to compare 6 and 5. 6 is greater than 5, yes, so we have to swap. And remaining things we have to keep as it is. Okay, and 6 is greater than 8? No, so we have to keep as it is. Okay, and 8 is greater than 15? No, we have to keep as it is. And 15 is greater than 16? No, we have to keep as it is. Okay, so now we are end with pass 4, so I will name it as pass 4. Okay, so at the end of the pass 4 we got the expected output. Okay, so this is the graphical example I have given for you to better understand. Now let's begin with the coding part. Okay, let data equal to the input data and n equal to 5. Okay, so as we know we have 4 passes, that is n minus 1 passes. Okay, so we need two loops. One is for passes and another one loop is for comparisons. Okay, so we have to define 2 loops here. First I will write one function sort. Inside this we'll define for loop. I will take I is equal to 0, I is less than. How many passes we have? N minus 1. Okay, so that we have to give n minus 1 and I plus plus. Okay, so we need another loop for comparisons. Okay, for j is equal to 0, j is less than n minus 1 and j plus plus. Okay, so inside this loop we have to do comparisons. Okay, so if data of j is greater than data of j plus 1, okay, then we have to make swap. Okay, let temp equal to data of j equal to data of j plus 1. Okay, now data of j plus 1 equal to temp. Okay, so we'll call this method sort and we'll print a console log. We'll see the output now. Okay, yeah, this is the expected output. Okay, so as I told, we have 2 for loops, one for passes and another one for comparisons. Okay, so but we will optimize this code. Okay, as we see at the end of the pass 1 we got largest element of the given data. Okay, so at the end of the pass 2 we got largest 2 elements of the given data. Okay, at pass 3 we got largest 3 elements from the given data. Okay, so in pass 2, as we know 16 is the largest element, there is no point to compare with 15 and 16. Right, in pass 3 there is no point to compare 8 to 15 because in pass 2 we know that 15 and 16 is the largest. So obviously 8 will not greater than the 15 and 16. So there is no point to compare 8 and 15. Okay, and in pass 4, in pass 3 we know that 8, 15, 16 is the greater elements. In pass 3, as we know 8, 15, 16 is the largest elements from the given data. Okay, in pass 4 there is no point to compare 6 and 8 and 8 and 15 and 15 and 16. Okay, to avoid this type of unnecessary comparisons, okay, we'll modify this code. To avoid those things, we'll modify this code by adding minus I. Okay, the comparisons is depend on the value of I. See, in pass 1 I will be 0. Okay, that time we have 4 comparisons. In pass 2 I will become 1 and we have 3 comparisons. Okay, and in in pass 3 I will become 2. In pass 3 we have 2 comparisons. Okay, in pass 4 I will become 3. So okay, that time we have only one comparison. Comparison will depend on I. Okay, that's why we added n minus 1 minus I. Okay, comparison will depend on I. Okay, that's why we added n minus 1 minus I. Okay, still we modify this code. That's called optimized bubble sort. With this logic, our code will execute n minus 1 time. Okay, so I will give an example. I will give a new data like 1 2 3 4 5 6 7 8 9 and 10. And what's the n? N will become 10 and the possible passes, number of passes are n minus 1, that's equal to 9. Okay, so for this data, this loop will execute 9 times. Okay, so see, even the given data is sorted. Okay, even the given data is sorted, but still our loop executes 9 times. Okay, to avoid these things, what we can do, we'll check the condition. See, we need to check the condition like in this pass whether swapping is happened or not. Okay, see, in pass 2 for the last 2 iterations there is no swapping. In this pass there is no swapping for last 3 iterations, and in this pass there is no swapping for last 4 iterations. Okay, so what we need to do, like we need to add one condition here. Let is swap. Okay, we'll make it as false, and you have to make this here to only if the swapping is done, then only we have to make it as true. And we have to check one condition here for out of this for loop. If is swap is false, then we have to break. Yeah, this is all about the optimized bubble sort. Yeah, we'll see in the next session. Thank you.